Welcome back. This is the third recording. Now, I hope you had a chance to try out these different graphs using either the graphing calculator or Desmos. And hopefully you found that if I graphed, say, r is equal to 4 cosine of theta, 2 theta, you ended up with this kind of graph. Cosine of 3 theta would be this. R is equal to 4 cosine of 4 theta would be this. And R is equal to 4 times cosine of 5 theta is going to be equal to this. Okay, so these are what we call roses. What does it look like? Roses. So this is what we call roses graph. Rose curves. Okay, it looks like roses, right? Now, what you should notice is that when n is equal to 2, I have flower or rose with 4 petals. Okay, so I have 4 petals. When n was equal to 3, I had 3 petals. And when n is equal to 4, I had 8 petals. And when n is equal to 5, I had 5 petals. Okay, so do you see a pattern in this? Well, it seems to make a difference whether we have an even number for n or odd, right? So what you should have discovered is that if n is equal to odd, if n is odd, then you ended up with the number of petals you end up with is just the same number of as n number of petals. However, if n was even, the number of petals in the rows, we ended up with 2 times the number of n. So here n was 2, so number of petals was 4. Here n was 4, so the number of petals was 8. If I had n is equal to 6, the number of petals I would expect would be 12. So here it will be 2 times n petals. Okay, so this is a pattern that you need to recognize. Is there any difference with the A? Well, the A is going to determine what we call petal length. Okay, so this is what we call, this distance right here is going to be called petal length. And that is determined by whatever the A value is. Okay, so that's another thing. So petal length is going to be same as A. Alright, so that's the quick summary of what you should have observed. An interesting thing is that, remember the circle that we graphed? This is really the rose curve when n is equal to 1. Remember, it's just like 4 times cosine of 1 theta. That's this curve right there. Okay, so that's what happens. Alright, so then let's move on to considering what is the difference between a cosine rose graph and a sine rose graph. And to do that, I want you to try to graph these two. Okay, so if I have r equals 5 cosine of 3 theta and r is equal to 5 sine of 5 theta. Can you try to graph that in Desmos or graphing calculator and try to draw it? Okay, I hope you had a chance to do that. So what did you discover? Hopefully you discovered that both of them created roses with 3 petals, and petal length is going to be 5 either way, right? So you ended up with 3 petals. Both have 3 petals, and petal length was 5. So because A was 5. What else did you discover though? Okay, it looked as with cosine, the initial ray, you always had a petal in that 0 degrees. And that is because cosine of 0 degrees is 1. So you are multiplying this to 1. So 1 times 5 is going to be 5 right here. Okay, so you always fill this. Okay. However, this flower Okay, so it's almost as if you could reflect this flower over the horizontal line. Okay, so this line right there is going to be symmetry. This is going to create a symmetry. Symmetry, it's going to be a line of symmetry for this is going to be a line of symmetry, and that is going to be because cosine of 0 degrees is 1. Okay, and in contrast to the sine graph, you have line of symmetry is going to be a vertical line. Okay, so this is my line of symmetry. And that is because sine of 90 degrees is going to be equal to 1. So you end up with sine of 90 becomes 1. 1 times 5 is going to be this 5. All right, so that's, you're going to always have this paddle there. If you are dealing with cosine, you are going to have a paddle on this, and whereas if you are sine, you always have a paddle in this position, and the rest gets formed by number of paddles. Okay, so then something else I want you to observe is, what do you think is the angulation between the paddles? Well, that really depends on the number of paddles, isn't it? Okay, because I know that the whole revolution is, if I went around, it's going to be 360 degrees, and it's being evenly divided by 3 of the paddles. So this angle right there is going to be whatever the 360 degrees divided by however number of paddles we're dealing with. So which is depends on n, if it's odd, or so this will be number of paddles. So what that means is, in this case, what is this angulation here? That's going to be 320 degrees divided by 3. So that is going to be 120 degrees. What about this? This is 360 degrees divided by 8. So this is going to be the angulation here is going to be 360 divided by number of paddles, which is 8. That's 45 degrees. And here you have 5 paddles. So the angle here is 360 divided by 5, which is going to be 72 degrees. So that helps us to be able to graph pretty accurately. Okay, I have another question now. What happens if A is negative? Okay, to do that, I would like you to try to graph R is equal to 5 cosine of 3 theta. R is equal to negative 5 times cosine of 3 theta. And also do the same thing for sine. And can you try to graph it and draw it? What happens? Okay, so if I was to draw that, it will look like this. What does it look like? It's as if I've just reflected this over this line here. What is that line? That line here is that what we will call line theta is equal to pi over 2. Okay? And it's as if we've reflected, so it looks like a reflection over the line theta is equal to pi over 2. So that is the vertical line. We used to call that the y-axis, but we do not talk in terms of x and y-axis because we don't have the x and y-axis anymore, right? Whereas if I did the same thing with sine curve, it's as if I have reflected over the horizontal axis. And what is the horizontal line? This is where theta is equal to 0 degrees or 0 radians, or we also call that the polar axis. So what it looks like is, it looks like we reflect, it's a reflection over the line of symmetry as if theta is equal to 0 or the polar axis. Okay, great. That's all about the rose curves. Now we're going to look at some example questions. So if I give you this equation, r is equal to 4 cosine of 7 theta, how many petals does it have? Well, in this case, we know that n is equal to 7, right? So this 7 here, right here, tells us how many petals we're going to have, and which is odd, right? If this was even, you would need to double it. But since it is odd, then the number of petals would be just the n value, which is 7 petals. Okay, now this time we're being asked, write an equation of a rose with 8 petals and petal length of 14. So that means petal length of 14 means we have A is equal to 14 and the rose has 8 petals. Okay, so this is going to be even, right? This is even. That means 2n is going to be equal to 8, right? 2n. So that means n is going to be equal to 4. So therefore, the equation that's going to give me 8 petals and length of 14 is, if I was to use cosine function, it will be r is equal to a is 14 times cosine of 4 beta. Or I could have said r is equal to 14 times sine of 4 theta. They would both give me roses, and they would have slightly different orientation, but they would both give me roses with 8 petals and petal length of 14. Okay, so this is all about roses. On the next video, we're going to be talking about the last type of graph, which is what we call lemniscates. Okay, so we'll continue on the next video.